we're going to, as an industry, have to work on costs unless we want things to die. How does a youngster today afford to get an airplane or an airplane license even? Getting more kids into aviation is important, but making it affordable for them to stay is also important.
Welcome back to Aviation Masters, a podcast where we have long talks with aviation's most fascinating people. I'm your host, Mike Bush. And in this episode, this is one I've been looking forward to for a long time. I'm joined by a good friend whose life has been absolutely fascinating, Dr. John Torode. He's a PhD in physics, I think maybe computer science. And he had a very long career in the high-tech world that we'll talk about a little bit. And then in, I think, 2000, he founded Dynon Avionics, which has basically become the dominant avionics force in the experimental world and is making significant inroads now into the certificated world. And then in 2012, he did something absolutely insane. He started another company called Vashon. This is like one of those classic make a small fortune in aviation by starting with a large one and knowing when to quit. But I want to explore why you did that. And in fact, we had a number of conversations because John wanted to design his own engine. He wasn't satisfied with Rotex or Continental. So, but at any rate, John has spent the last 25 years reshaping the economics of general aviation in a way that's, I think, very significant. A really fascinating guy. John, I like most of my guests on this pod. These are people that I've known from aviation, but I always like to learn a little bit about their lives before I met them. And when I was doing a little research on you, I was absolutely blown away by some of the parallels between the two of us. We were both born the same year, 1944. So we're both. I will be 82 in August, and you just turned 82, so we're the same age. And we both got involved in the computer revolution back in its earliest days. And then when we got into our late 50s, we both decided to make a change and to turn our longtime avocation into a new vocation. So it was just very interesting. I'm actually kind of amazed that I didn't meet you when I was in my late 20s or early 30s because I believe you were involved with Gary Kildall, CPM in the 8-bit microcomputer thing with the Z80s and so on. And I actually did a little work with Gary, but I developed, I started a company that developed a CPM compatible operating system that had essentially integrated LAN capabilities so that you could run a whole slew of them together and they talk to one another and share peripherals and so on. So we were messing around with all of that stuff pretty much about the same time. But anyway, let me just go back to your education. I believe you got your undergraduate degree at MIT.
Affirmative. I think back when it was a little easier to get in.
And you were class of 66 at MIT when I was class of 66 at Dartmouth. And you majored in physics at MIT? What corner of physics were you involved in?
By the time you get a bachelor's degree, you've basically spent time in all corners. Physics was great. It tells you how the world works, right? Why this thing moves when I push it, why it stops when I stop pushing, why your fingers itch when you stick them in a fork in the hole in the wall.
So you're one of the 12 people in the world that understand quantum mechanics.
No, that's why I retired. The second years of graduate school start getting very, very mathematical. Basic physics gives you an understanding of the real world. First, I think it was Einstein who said, if you think you understand quantum mechanics, you don't.
Yeah, right.
And relativity and quantum mechanics are things you'll never see. They really are real. They really happen. They really tell us why things work. And I've been a semiconductor guy much of my life. And without understanding quantum mechanics, we never would have gotten semiconductors to work. But it's largely a mathematical exercise. I had spent a lot of time putting computers into physics experiments. And when I essentially flunked out of graduate school in physics, I either had to go to work for Boeing or stay in school. So I switched to computer science. And by the way, I don't use the title doctor unless I'm dealing with the medical profession, then I insist on it.
Okay, fair enough.
The great thing about graduate school is, first, all good engineers, and maybe I'm one, maybe I'm not, but all good engineers are happiest when they're learning, when they're doing something new, when they are facing a problem that requires research into what's going on here. And graduate school is that on steroids. I spent 12 years in college, if you count my 5 years teaching at Berkeley, and it's a wonderful environment for learning. And you don't make any money, but it's
You don't have many expenses yet.
Well, actually, no. There's a bit of my history you won't know.
Okay.
I'm in graduate school in the University of Washington. All of us got a teaching assistantship, which paid $300 a month. Yes, that much. On $300 a month, you could almost, but not quite, live and eat in Seattle at the time. So I and all my friends were dead poor. And then I started a small computer business, and I had 5 clients. I ran their payrolls and accounting functions. I rented time on a computer, and that made me another $300 a month. So all of a sudden, I had infinite discretionary income compared to all my friends who had negative. So I learned to fly, of course. And you could do that on $300 a month back in 1967.
You learned to fly after you graduated from MIT, moved back to Washington.
Right. I was in graduate school when I learned to fly.
Back at Washington, University of Washington.
Affirmative.
Mm-hmm. I was between, I guess, junior and senior year at Dartmouth when I learned to fly. So
we used to say rude things about the guys from Dartmouth, which I won't repeat here, but my boss, T.J. Rogers, when I merged my small semiconductor with his large one, was a Dartmouth guy. And my president here at Dynon for years, Robert Hamilton, was a Harvard graduate, and we never let him forget that.
Well, I was a math major at Dartmouth, and Dartmouth was a really good place to be a math major.
Yes.
And so I got hooked up with John Kemeny, and John was very interested in bringing computing to the Dartmouth campus, and so I spent a lot of my undergraduate years down in the basement at College Hall where we had the computer.
Yeah, a big computer. Yeah,
but I actually started programming when I was in high school. I got a chance to program an IBM 650 at IBM.
Hey, so did
Watson
I.
Labs. Did you really?
So
with
did I in high school.
A zillion vacuum tubes, and they never, they were always blowing out. And the thing required this gigantic air conditioning system, and it had 2,000 10-digit words stored in binary.
The SOAP 2 optimizing assembler.
Yep. Yeah.
Yeah.
Yep. That's just amazing.
God, you and I are dinosaurs.
No, we absolutely are. We absolutely are. So, and I also seem to recall that the one of the first. Well, I'm getting ahead of myself. So anyway, you went back to University of Washington, and you got a master's in physics. Did you ever get into computer science, or was it physics all the way?
No. I flunked out of physics, and they issue you a master's on the way out. I had actually discovered mountain climbing, so all my summers were spent somewhere interesting, and if you don't spend all your summers as an academic, you don't advance. So I flunked out of physics. I got a master's. The computer science department had recently been formed at UW. As I mentioned, I had a small company doing computer programming, so I switched over. And I actually collected college degrees for a few years. I discovered that I had passed all the requirements for a master's in computer science. So I filled out the form, took it to my advisor. He looked, what's this? Why do you want a master's? You're getting a PhD in 3 months. I looked him in the eye and said truthfully, so I will have more college degrees than my friend Jim Martin. And I did, and I do.
You'll be happy to know that after Dartmouth, I entered a PhD program in mathematics at Princeton, and I flunked out of that.
It's a good school for math.
It is, and I was on a trajectory to be a math professor, and I just said, I have to get involved in this computer industry, and there wasn't any way you could do that at Princeton, and so I wound up bailing out, and I never did get my PhD.
Well, there was one instance in my life where having 5 college degrees was a benefit. I'm sitting at the gate at O'Hare waiting for a flight, and there's a woman and a daughter sitting next to me, and I'm trying to do some work, and the daughter says, Mom, it's an A, and the mother says, no, it's a B, and they go back and forth, it's an A, it's a B. So I shut them up. I turned to them and said, no, it's an A, and the mom looked at me and said, oh yeah, how many college degrees do you have? And I looked her in the eye and said 5, and she shut up. Other than that, having 5 college degrees merely meant I was a dilettante.
So you actually did pursue an academic career, at least for a while, but you were starting businesses at the same time somehow, with feet in both rowboats.
My academics in computer science started after I flunked out of physics. But I got to give you an interesting statistic I came across or computed the other day. At MIT, there were 10 guys in the EE department doing computer stuff, mostly hardware. I got to the UW and there were 8 official faculty in computer science, but there were 3 or 4 joint appointments. And I was the 13th and most junior faculty member at Berkeley for the founding of the formal computer science department there. So there you had 30 guys in 3 pretty good universities all doing computer work. Computer work back then was hardware, operating systems, and computer languages. Fortran had just come along.
Oh, yeah.
Today,
was my boss at one time, was the inventor of Fortran.
Yep. Today, each of those 3 schools has north of 200 faculty in computer science. There are now 600 people teaching the youngsters what was a cadre of maybe 30 years ago. And that implies a bunch of things. First, the world needs an awful lot of computer people. Second, what a computer guy is working on is way different from the early days. Very few of them are now doing hardware. That's being left to the Intels and NVIDIAs and TSMCs of the world. You can't build state-of-the-art computer hardware unless you have a $30 billion factory, and no universities have those. Languages are kind of weird in my view. They've stagnated. We had SOAP 2 on the IBM 650.
We've now come full circle where the main programming language is English.
Yep.
Which is kind of remarkable.
Okay, here's the weird thing. I took my first programming class my freshman year at MIT in '62. It was taught by a professor named Marvin Minsky.
I know Marvin Minsky.
Okay, Great. He was the AI guru of the 60s, 70s, 80s. And he predicted, in my hearing, a bunch of things that AI would do, including passing the Turing test. Can you tell the difference between a computer and a human? And he predicted all those things would happen within 10 years, i.e. by 1972. It took 50, Mike. It took 50 years. And therefore,
and 45 years in, they still kept saying, "Oh, it's another 20 years out, right?" And then it suddenly happened.
It's somewhat like fusion power, right? The fusion power generation has been 50 years in the future for the last, since 1958, and it's still 30 to 50 years in the future. It's a very hard problem. Here's a physics question for you, Mike. How much power is generated in the sun per cubic meter?
I do not know the
know?
answer just offhand.
The answer is 2 watts, not enough to light a light bulb, even an LED light bulb. 2 watts per cubic meter. Now, the sun has one hell of a lot of cubic meters, so it ends up amounting to a lot. But in order to do a power generator using fusion, we're going to have to up that 7 orders of magnitude more than the power generation in the sun. That seems like a hard problem.
It is a hard problem.
Yep. So there are in fact 3 startups doing fusion reactors in the Seattle area as we speak. And I don't know, I think it's going to be a while before we have useful fusion reactors. Maybe 30.
At any rate, we'll get back to you after starting a few companies. You started a company called IC Design.
I did,
and that was basically designing silicon.
Right.
You weren't fabricating it, right? You were designing it.
Yes, we did.
You had a fab?
No, we rented a fab.
Okay,
So I had sold my PC company to our UK distributor in 1984. It became very important that my wife and I were not residents of the state of California that year.
That's very important.
We quickly moved back to Seattle and formed a couple of companies. One was called IC Designs. My thesis advisor at UW had developed some software for doing layout and testing of ICs. And the university became a shareholder in that company, and we commercialized that software. And the idea was that there were 300,000 electrical engineers in the U.S., 600,000 in the world, and about half of them would buy our software and design their own chips.
This is what they now call EDA software?
Maybe, but I'm not a good acronym guy.
Electronic design automation?
Yeah. We developed a technique called a multi-project wafer where I could take your design and 15 others and pay back then it was only about $25,000 to buy a mask set for a 1 micron process. Laughable, 1 micron. We're now at 5 nanometers. And I could build a bunch of your parts, and if you liked the part, if it worked, then I could spend the $25K for a mask set and build parts just for you. Again, our business plan was to sell 100,000 copies of that software, and I believe we sold 10. So the company is failing. We're about to shut down, and my sales guy comes to me and says, I cannot sell software, but I can sell chips and chip designs. Why don't we use our own software to design a family of chips? We did, and that took this company from about to be shut down to absolutely coining money in about 2 years.
Wow.
So my customers were Intel, Compaq. You remember the Compaq computer?
Mm-hmm. And I heard rumors that one of the chips you designed early were controllers for floppy disks.
I did. That was a collection of chips back when medium scale integration was a thing. And that's how we got my relationship with Gary Kildall. I built the hardware. He built the CPM software. I wrote all the I/O part of the operating system, and he kept the software part. I kept the hardware part. You intrigued me by you built computer networks. What made my company really successful was building a computer network. The expensive part of a PC system in the early 80s was the hard disk. I have sold many a 9 megabyte, get that, 9 million byte hard disk for north of $10,000 each. And today those are laughable numbers, but back then it's what the state of the art was. We built a computer network that would take a collection of Z80 microcomputers with a screen of some sort, network them together, and share the hard disk. My best customer was the radio paging company in Hong Kong. You know what a radio pager used to be before cell phones. And we outfitted a room with 30 operators all working on one of our computers and sharing one hard disk to do the messaging and communication for a radio paging system. That's what made that company. And when I sold it, I had more money than sense and started a semiconductor company. As I just mentioned, it was about to fail when we completely changed direction and it went gangbusters. It attracted Cypress Semiconductor because the product line we had come up with, phase lock loops and frequency synthesis, fit their growth model. And they acquired me, made me an offer I couldn't refuse, which of course has given me enough money to work in aviation. Yeah.
Well, I'm just struck by the parallels. I'm just amazed that you and I didn't meet in a prior lifetime, because we were doing a lot of the same stuff at the same time.
Particularly back when there were only a couple of hundred people doing it.
You did it a lot more profitably than I did.
Well, maybe.
You had better sense or better timing, at any rate.
So, you still eat, right?
Yeah, I'm
okay. So I don't need to feel sorry for you.
No. I figured, if you have enough money that you don't have to worry about money, then that's enough. So
you've heard the old British saying that income 19 pounds sixpence, outgo 20 pounds disaster. Income 20 pounds sixpence, outgo 20 pounds bliss.
Yes.
So if you have enough money isn't an issue. If you don't, it's a disaster.
That's right.
But it takes more than enough to get into aviation.
So any rate, after this meteoric career in the world of semiconductors, and of course I went into software because I was a math major, and you wound up getting into chips because you were a physics guy. So
yeah,
that all makes perfect sense. So any rate, fast forward to when we both got into our 50s.
Yeah.
And decided we've been doing this for quite a long time, and we've both been flying airplanes all this time, having, as a hobby, sort of.
Yeah.
I hate to use the word hobby with aviation, because aviation is too serious a business to be called a hobby. But we were doing it as an avocation, and we both decided that we were going to try to see if we could make a vocation out of it. So you started Dynon, and talk us through the process of your deciding to do that.
Okay. First, the first 17 years of Dynon's existence, I had two jobs. I was chief technical officer of this modest-sized semiconductor company.
Cypress?
And that's Cypress. And in 2000, on a whim, I said, gee, how can I use the background I have in computers and semiconductors to improve the basic general aviation airplane? And you got to go back to 2000. Everybody has got glass all over his panel and GPS receivers and knows exactly where he was. But back then, the avionics was pretty primitive. In '84, when my wife and I moved out of California in a hurry, we flew our Cessna 150 from Oakland up to Seattle, and the weather was crappy, so we had to go east of the Sierra Nevada and east of the Cascade Mountains. And let me tell you, there are very few VORs out in eastern Oregon. And literally, my wife had her finger on the map. We just passed the river. We just passed the road. And that's how we knew where we were.
You weren't using Loran. Shame on you.
I didn't even ever get to Loran, right?
I had some Loran in my airplane, and I flew it up to Alaska. Do you know how bad the geometry is for Loran in Alaska?
Today we are immensely spoiled. The GPS tells us where we are within a few meters, and that's when we're flying at 50 meters per second at least. So
the other thing that's crazy is I one time counted up how many GPS receivers I had in my airplane, including my phone and my iPad and everything that was running it. Everything has a GPS receiver in it now.
One of the first times I flew one of my airplanes up to Canada, out in the boondocks, I made sure I had 5 working GPSs in the airplane. And indeed, two of them went sideways on me because of battery issues. But it's astoundingly important until it isn't. I've got a good friend who drives 747s for UPS, and 2 months before the war in Ukraine started, he's flying over Crimea, something like Dusseldorf to Dubai, and he looks and he turns to the FO and says, "That's odd, number one GPS just quit." And a minute later, hey, number two is just gone.
Somebody's jamming something.
Yep. A 747 has got 3 laser gyro INSs aboard, and they kept him going and lost a mile an hour in location. And when he got a long way away from Russia and Crimea, the GPSs came back. But it is both an astoundingly useful service that the satellites provide, and vulnerable when it goes away. The signal you're receiving for GPS is astoundingly wimpy. A modern GPS can track a GPS satellite at something like minus 165 dBm. You're a mathematician. You probably know that at the nanovolts of signal. And it doesn't take much of a jammer to make that signal unreliable. And that is, of course, what we are seeing now in the conflict zones of the world, all over Ukraine and Western Russia, all over big chunks of the Middle East. GPS is not a reliable thing.
I was always a little surprised that our spark ignition engines didn't produce enough RFI to take out all the GPSs, but apparently they don't.
They're probably nowhere near the bed frequency. It's 1.5 gigahertz, and that's pretty high. But yeah, spark ignition engines certainly can interfere with some electronics, including avionics. Indeed, it can.
So what at the time you decided to start Dynon, what was the general state of avionics, and what was your vision for that caused you to start Dynon?
I'm going to remember badly, but there was a company called Sierra Aviation that had a 5-inch EFIS doing attitude PFD kind of work. And when we got started, I got a bunch of their advertising postcards and stuck one on the computer of every one of the guys that was working on ours. This is a $25,000 instrument, so well beyond the average GA airplane, but not beyond the doctor driving Bonanzas, maybe. And our goal was to do something similar, but way more affordable. My whole successful business history has been taking technology, the 8-bit microcomputer, ability to design your own chip. We also built pen plotters for a while. Taking technology to make an existing capability affordable. When we brought out our first PC, it was a Z80, 32 or 64 gigabytes of RAM, 2.5 megabyte floppy disks. Laughable capability today, but we got $8,000 for it because the closest alternative was a Digital Equipment Corporation PDP-8 for $85,000.
Right.
For $8,000, you'd think about computerizing your father-in-law's laundry, right? Doing his accounting and data keeping. For $85,000, you wouldn't even think about it. So,
right. In fact, when I started my first company, because I went to work for a Fortune 500 company first. I went to work for Computer Sciences Corporation.
Yes.
And I was involved in doing a bunch of projects on many computers for National Cash Register and so on at CSC. And when the 8080 came out, of course, I built my own MSI computer at home and soldered all the boards and everything. And I wound up going to the CEO of CSC and trying to persuade him that microcomputers were going to change everything, and CSC needed to start a new division to get involved in microprocessors. And he listened to my passionate pitch and then said to me, and there was a very big age difference because I was in my 20s. He said, "Son, there's never going to be any money in those things," and that's when I decided to leave the company and start my own company.
So the IBM made exactly the same mistake, right? They decided that, hey, this microcomputer thing, we can't just ignore it. We better get involved. And then they issued Bill Gates a license to print money. They gave him control of the software.
Well, as I recall, they wanted to give that license to Gary Kildall, and he was non-responsive, so they went and talked to Bill instead.
Yeah, that's a long story in itself. Gary and his wife both firmly believed IBM would be the death knell of microcomputers. Therefore, they were not very cooperative. But Bill Gates, being a tad smarter, did cooperate, and the rest is history.
It sure is.
Here's the thing. IBM, I'm guessing, had thousands of scientists who worked for them who knew that if you want to build a gigahertz computer, it has to be smaller than that. Electrical signals in a wire move at the speed of light in copper, and that's about 9 inches per nanosecond. So a gigahertz is a nanosecond clock rate. If you want signals to get from here to there, they've got to be smaller than that. And IBM was still building rooms full of computers. Now, Control Data built the original Cray 1. I think it was a gigahertz computer, but all of the timing was done in lengths of wires. And while the clock rate was a gigahertz, things were pipelined and staged to get done in that. But IBM could have known in 1982 or whenever the IBM PC came out, yes, this is a laughably inefficient and small computer by today's measure, but they could extrapolate Moore's law as well as anyone, and they knew that to get to a gigahertz, it's got to be that big. So I got to sidestep with a story. In 1969, Scientific American magazine.
Yes.
It had a whole book on information theory. Everything from hardware, software, math. And I'm in the middle of graduate school in computer science, so I saved the book. 13 years ago, my wife and I tore down our cabin in the woods and built a new one. Actually, we built a house. And while we were cleaning up before tearing down the old cabin, I found this magazine. Big book, 170 pages. Mike, I went through it. 85% of the full-page ads were from companies that no longer existed.
Mm-hmm.
And one of them was Kodak. I was a director of one of Kodak's subsidiaries in the 80s, and I got put on a committee to study digital film. And was this 86, 7? And in that year, a digital camera was crap, 600 resolution maybe. And yet I knew Moore's law, and my input to the committee was, yes, it's crap today. It'll be half as crappy tomorrow, and a 64th as crappy in 5 years, that it is going to overwhelm us. No, it's always going to be film. And Kodak no longer exists. Anyway, I respect Bill Gates for a couple of reasons. My wife and I like to think we built his first computer in our spare bedroom, but he has been quoted on a radio interview of saying, look, no company, even Microsoft, has the right and expectation to live forever. Microsoft is certainly on a roll now. They're good for a while. The other thing he said in a different interview was basically once you decide it's not a healthy thing to leave $50 billion to your kids, you've got a lot of freedom to decide what you're going to do with it. And I think that showed a remarkable piece of insight that if you look at history, the second generation of rich folks doesn't do as well as the first or the third.
Well, so
anyway,
let's getting back to the origins of Dynon. You saw that there were glass panels that were going for $25,000-$50,000, and you said, why could they? That's ridiculous. Why would they cost that much?
Yep, and a PFD.
Of course, part of the reason they cost that much is because they were certified, right?
Of course, which is why we got started in the uncertified world.
Now, were you flying a an experimental or anything?
No,
Or was this a whole
no.
new world for you?
All of my airplanes that I've owned and flown have been certified. I certainly never have had the time to invest 5 years in building an airplane, and I have great respect for the people who do.
I don't have the attention span to do that.
Exactly, I don't either.
I've always said I would love to do that, but I know, the percentage of unfinished airplane projects is very, very high. And I know
Is it?
in my heart that I would be in that category. I would just start it
Yep.
and never finish it.
I also think that's probably a defect in the business plan of some companies, that those unfinished kits are going to get sold someday by the widow of nobody else, and somebody's going to finish them. But to do a PFD like our very first product, hey, I did not put this here for this talk, but I have one in front of me. This is our D10A. It's a laughable 4-inch screen. It's got 6 buttons.
That was the original product?
That was our original product. It did airspeed, attitude, heading, a bunch of other things, including a G meter. But to do that product, you need a bunch of sensors that measure the real world. What is the magnetic field in 3 dimensions? You need a computer that can take that raw data and turn it into something useful to a pilot. And believe it or not, there's 2 copies of an 8-bit computer that I designed in this thing.
Now, that thing doesn't have an Adahars in it, does it? That is
No, it
relied on
doesn't.
external.
It does indeed, to
Does it
show
really?
you where sensors have come. The very first version of this had 3 British Aerospace Japanese joint venture that built, we call them gyros. They are rotation sensors. They put out a voltage that gets higher as the rotation rate goes up. You need 3 of them to do all 3 dimensions, and they back then were $60 each. So I had close to $200 worth of sensors for rotation to get attitude. You also need magnetic field and acceleration for sure. And to do airspeed, you need differential pressure sensors. So we probably had $300 or $400 worth of sensors in this box. We had 2 chips that I invented, and because I was still working at Cypress, got friend of the family pricing, but I had $3 worth of computers in there. The screen was maybe $400.
What year did that come out, that product?
We started in 2000. I believe it first shipped in 2002 late.
Wow.
But we got it done, and it was very hard to get it to work. Debated the price, and we thought, gee, the competition's at $20,000. We can get 5. But again, my business history that's successful has always been selling a product at volume. And I sold 100,000 PCs in 7 years. Laughably small number today, but it was maybe half or a third of the PCs that had a file system and an operating system back then. So we came out at $2,200. And my kit was astounding, the reaction. I believe there are guys who were building the airplane that never finished, that bought one of these and still have it in a box somewhere, because the idea that I can get a color screen EFIS on my panel for $2,000 resonated. It was an order of magnitude cheaper than the next alternative. Man, over time, we've sold 12,000 of these. And I sold the last one in 2024. It's a backup to our certified product line. And as such, I had to keep making these, even though my own chip had been end of life. And while I paid $1.45 for them when I was also manufacturing them.
This is the microcontroller?
It is an 8-bit micro with a whole bunch of analog capability, A to Ds, D to As, op amps. I paid $1.45 to my own employer to buy the first 12,000. I paid $109 each to some guy in China who had 100 of them and I didn't, in order to keep that production going. That's 100x what they were worth, but it enabled me to continue selling not only a $2,000 instrument, but a $15,000 system to the certified guys that needed that as a backup. I don't know where I'm going with that, other than only in aviation does a product last 22 years. And I've heard it said
remarkable
that only 2 products in aviation have ever sold 100,000 units. The Apollo, then GPS-based Garmin 430 has sold about that many, and the Bendix King KX76, was it, transponder, sold about that many. No other product in aviation has sold that many units. Certainly none of mine have, but 12,000. As a hint about how different our business is, the average TV set is on the market for 90 days. And then they change something, probably just to make it cheaper. You might not notice the change, but it's different. The average tennis shoe is on the market for a few months. And the modern world has product development in leaps and bounds. But I've just hit on the 2 problems, and the problem and the solution in aviation. The unit volume is very close to 0, right? We do, counting Boeing and Airbus, maybe 4,000 or 5,000 airplanes a year. Last year, we did 84 million automobiles. We are noise. And one of the biggest problems in aviation and avionics today, which I happen to know is affecting suppliers to Boeing, is end-of-life semiconductors. I paid X to keep this going while we got the replacement product certified. But many devices that we now buy for aircraft are on a life support limited supply of key semiconductors. It is a huge problem.
For the longest time, Dynon was selling only to the experimental market, and your venture into certified stuff's much more recent. Why did you decide to do that and to tie a big ball and chain to your leg that like the FAA puts down there?
Okay, as a pilot, you take a solemn oath to bitch and moan about the FAA every chance you get. But I'm saying some nice things here about them, not because I am now dependent on their goodwill, which I am, but because the following story is true. For 15 years, pilots would ask the FAA, hey, can I put this in my airplane? And the answer was always, of course not. You might look at it. And it's not certified. We made the argument, gee, if that instrument and others that we had been making by then improve safety in an RV-7, why wouldn't they also improve safety in a 172?
Of course. Is that what led to the Norsey thing?
No. So I guess I'm telling a story out of school here.
That's the best kind.
I am quoting an ex-FAA guy who was there. At Oshkosh every year, they organize a parade of the administrator and a whole bunch of his cohort that stop by 8, 10 dozen different booths at Oshkosh. And they get filmed for the record, and the administrator gets educated about what they do. And when Huerta was the administrator, he stopped by our booth, and my guys happened to do a very good job of explaining the safety features of our stuff. By then, it's a 10-inch screen with maps and the whole 9 yards. With that system, you never get lost. GPS, and you can put 2 on the system, will always draw where you are on the map. Instead of my wife running her finger up the map, There's a little airplane, and that's you on the map. You know exactly where you are, where the nearest airports are, etc. You also, if you happen to inadvertently get into a cloud, you don't run into rocks because we paint them all red on the screen, and it's quite obvious where the rocks are. So our argument was this is a safety enhancement thing. According to an FAA guy, now retired, after they left our booth, Huerta turned to him and said, "Get these guys an STC from the top." We had a project going, and the project manager at the Seattle ACO was himself interested in small airplanes and was very supportive. But he knew there was going to be resistance upstairs, and he said basically, if this project going to happen, you got to get help upstairs. And Huerta gave us that. I give them a lot of credit. The FAA sent 13 meetings with us for 5 days, 400 man hours. 7 of the people, including very senior folks in the FAA, met in our conference room. 6 of their people were on the phone. At the end of a week of discussing how can we do this, how can the FAA bend, how can it not bend, we came up with maybe a 10-page document that said if Dynon does these 10 pages of improvement, we, the FAA, will issue an STC to put the equipment in certified airplane. It was not trivial. For example, the requirement is lightning protection. We had none. We were prepared to say, yes, if your airplane gets hit by lightning, we die. But the FAA had rules that had the force of law that said you shall have lightning protection. So we had to add that.
Is that just a matter of shielding, or is that involved?
Oh, gosh, no, it's very complex.
Redesign.
A direct hit by lightning, forget it. Everything in the airplane. Now, actually, it's not true. I've been on 2 airliners that were hit by lightning, and in both cases, it was fill out a bunch of forms and have the mechanics come do a bunch of tests, but nothing serious died, to my knowledge.
Yeah. It was
but induced lightning can still give you thousands of volts. We had to put significant additional protective circuits on some of our critical pieces of gear. But the big thing was certified software.
What does that involve? I've always been curious about how that works.
Oh, gosh. There is a process known as DO-178. It is a standard written by standards organization, RTCA, that says how you develop software for a safety critical environment. For example, you want to run a nuclear power plant. You need DO-178 software. You want to run a train locomotive. The software better be certified. And it is extremely complex and very documentation specific, and in the end requires an audit of every line of your code. And there are levels of safety. Design Assurance Level A says, we don't even trust your compiler. Let's look at the binary. And much of the avionics world now does its auditing of DO-178 software in India, where it still costs about $100 a line of code to get it certified. Okay, that's a lot of money for any real system today. And last I counted, we had north of 2 million lines of code. I've had 10 people working on our current product, Skyview, making improvements, adding features, adding sensors for 14 years now. So there's 140 man years generating code.
Question that just occurred to me. Nowadays, couldn't something like Claude or somebody do that auditing?
To my knowledge, no. Today, someday, for sure. Okay, we are already using AI, into which we have dumped the Part 23 certification rules for an airplane, the Mosaic rules as they are currently existing, the ASTM rules for a light sport. And I saw a demo yesterday. What are the regulations we must comply with on seats and seat belts? And the AI came out with quoting chapter and verse of the various Part 23 ASTM Mosaic rules regarding seat belts. Now, AI is probably making its biggest impact today in software development.
Absolutely.
One of the big things about DO-178 is you are not allowed to DO-178ize software you've already written. You must start, before you ever write a line of code, there are a whole bunch of, they're called artifacts you have to develop. Basically, a requirements document. This product must do A, it must do B, it doesn't need to do C. And that needs to be very detailed. And one of the tests is every line of your code has to be traceable to being involved in one of these requirements. So
you're saying you can't retrofit
totally
the
disallowed. And we had 2 million lines of code.
Yeah.
And $200 million to certify it. It was laughably out of reach. But DO-178 has a statement in it. This is one way of meeting the requirements. There may be alternate means of compliance if acceptable to the administrator. And that was the out that allowed us to work out what is an acceptable means of compliance with the safety criticalness of the software without doing $200 million worth of auditing.
So you proposed an AMOC and got them to sign off on it?
Let's say we developed it jointly with the FAA. They were willing to bend because the administrator wanted to get our product into 172 for safety reasons. They weren't willing or able to break any of their hard and fast rules, but we did come up with an alternate means. And, I'm not allowed to use the G word.
Costs less than $200,000 to
$200 million.
Or $200 million, I'm sorry.
Yep. It probably cost us maybe $2 million to go through and organize our software and run the tests that we in the FAA agreed in order to meet the alternate means of compliance. And let me tell you, our competition is allowed, certainly they should be if we're allowed, and now use that alternate means of compliance, because anything in a modern airplane that does everything a pilot wants has got 1 million lines of code in it. There are 20 boxes. Each box has got 1 to 3 computers in it. They're all programmed. Certainly not allowed for airliners. If you want to put your product in a Boeing,
that's
then
a whole different level.
You're going to use DO-178. And we do. We now have a division in Europe, why we are now called the Dynon Group. We acquired Trig Avionics a year ago. And everything they build is certified through EASA, not FAA, but jointly certified by treaty. And everything they do is DO-178, and it is expensive, but it is a large number of point products. They have a comm radio, a nav radio, a transponder. Each of those point products has much less software than it takes to draw a map on a screen.
Right.
And therefore, it is doable under DO-178. And we have worked with Trig for 20 years. They have been the transponder in our systems ever since. And when they became available, we bought the controlling interest in the company in order to own that one more component of our system that the customer has to have. He has to have an ADS-B out transponder today to be a viable system. And we were buying, not making that. Now we also make it. Your question about AI, I told you earlier my reasons for believing there's too much hype involved. The industry is going to spend $750 billion this year buying data centers and hardware to run AI stuff on. The cynic in me is skeptical that the returns on that will ever justify $1 trillion a year, and it's going to be for several years. It is going to impact most humans in some ways. For example, I get summaries of many of our meetings now that are done by an AI who's listening to the meeting, and these summaries are pretty good today. Our software developers are using AI at what today is a modest level. You may be aware that the Microsofts, Amazons, Googles, Oracles of the world have laid off significant numbers of programmers lately, blaming AI efficiencies as why they don't need them. It is going to change the software industry dramatically. I have often thought, you and I programmed on primitive assemblers back in the 60s. Then did along come some higher level languages, Fortran, COBOL. C is, in my view, a glorified assembly language, but the glory has gotten pretty good. But in the last 20 years, there has been no dramatic productivity improvement in generating software. There are all kinds of tools that are useful, debug tools, text editors, color coding, different syntax in your program. But basically, it was still humans writing code one line at a time. I do believe that AI will be able to do a lot of that.
Well, I'll tell you a little quick story. Savvy Aviation has a small IT operation that develops our software platform and everything. And I have a very good CTO who's been with us for years. For years, every time I went to the CTO with an idea of something I wanted to add to the software, the response was always, okay, well, what other projects in my pipeline do you want me to delay in order to do this? Like, it was just a standard answer. So I had a meeting with the CTO last Tuesday, and he said the following to me during that meeting. He said, Mike, we have now reached the point where we are completing software projects faster than you can feed them to us.
Ha! And he admitted this. Amazing.
This was totally based on the fact that AI is turbocharging the productivity of software development.
So an illustrative story, do you know what hackathon is? Where a bunch of computer hackers get together and they do a complete app in a weekend. And the guy sends one of his programmers to hackathon who does this. And when he gets back, he says, okay, I need to change the color of this icon here. That'll take 6 weeks. We just did an app in a weekend, but
yeah.
Okay, I'm at Cypress in 1994. We needed to change one character. We needed to add one character to our marketing part number. 105 programs had to be changed. It became almost a year massive thing to add a digit to a part number. You know what IBM's biggest business today, I believe, is, from what I've read, is keeping old systems alive that are doing giant things. For example, Visa credit card processing, billions of transactions a day done on old hardware. The cost of change is infinite, therefore we have to keep it running.
Yeah.
But I wish my software guys, and I think I have 20 now, we are in fact primarily a software organization. I wish they'd come to me and say, hey, we're running out of things to do because we have a lot more on the list.
Well, John, based on my experience, I bet that will happen and not too far in the future. I thought that was a real watershed event.
It is. I went to an AI conference at the University of Washington last year with Henry Kissinger, Eric Schmidt, and Craig Mundy. Kissinger didn't show up because he's dead. Eric Schmidt didn't show up because this was below his pay grade. Craig Mundy did. He was a retired Microsoft future strategist. The three of them had written a book on AI. couple of years ago while Kissinger was still alive. And they talked primarily about the ethics and how do we stop AI from taking over the world. The advantages of AI, and I spoke with Mundy after the talk, you and I are, maybe we're even slowing down, but we're basically a 4 hertz animal. We can do things 4 per second for a while. Humans, as you probably know, cannot multitask, and that gets pilots in serious trouble when things go wrong. They have trouble keeping the big picture and focus on one thing to their detriment.
I totally can't multitask.
No, people who claim they can...
They're mostly women, I think, who claim they can.
Yeah, probably they can. Women are different, but I'm not allowed to say that. But an AI, a computer is now a 10 to the 9th hertz animal, maybe a 10 to the 6th hertz thinker because it takes a lot of cycles, but orders of magnitude more than 4 hertz. So, for example, when you get to my age, you go to a room and you wonder why you're there. That's a classic meme. A computer would never forget why it went to that room. It would go down to the list. What's the next task? Oh, I'm in room 3. That means I go to the bathroom. But there is an advantage for AI. Here's another advantage. How long does it take to educate a human? 30 years is my estimate. He gets out of college maybe at 22, 3, 4. Yes, a programmer can do useful things right away, but before he really understands our product and our methodology and our rule book, he's been here a few years. A good engineer is really useful in year 28, 29 maybe. If I've got an AI here that is smart, how long does it take me to clone him? Hours, days at most. Depends how many gigabytes of whatever I got to transfer. So there's another advantage for AI. I was staggered by reading an analysis last month that you can buy a humanoid robot for maybe as low as $20,000 today. Amortize all the costs of operating that robot and let him work 30 days a month, 18 hours a day, and that comes down to $2 an hour.
Yeah.
$2 an hour for a humanoid robot. Now, their dexterity is nowhere near as good as these things we call fingers, but if there's a task you can have him do in the factory, and we're looking for one, we maybe don't have any, but we're looking for one. If that can be done for $2 an hour, we can move the $50 an hour people to way more productive things. Now, the worry is, of course, we'll lay off all the $50 an hour people, but that has never happened throughout history. You know who the Luddites were. They destroyed power looms back when weaving cloth was a labor-intensive thing. In fact, the Industrial Revolution in England and the world caused more people to be employed, not yet less. Japan, Korea, China are all now in very serious population decline. Russia, much of Europe. There is going to be a shortage of people in the next 50 years. So I don't believe the worry is that we will not have jobs for people who want to work. But
right.
here,
there's going to be some transitional dislocation, but I absolutely agree with you that
my chief software guy and I were in a discussion of AI recently, and he had read an article I had read that interviewed 4 very senior software guys who never write a line of code anymore. They spend all their time managing an AI that's writing the code. And my guy's comment was, okay, these are senior guys who are now becoming AI managers. What happens to the guy right out of college who doesn't know good code yet from bad code, who doesn't know how to manage an AI? How does a newbie get useful in that kind of environment? And I do see that as a problem.
Yeah, and I think we're seeing that right now, that graduates are having a harder time of finding initial employment.
That's a big problem today. I was talking to another of my engineers. His girlfriend graduated, I don't know, making it up, 4 years ago, got a job when they were hiring anybody, and she was pretty good, so she got a lot of promotion. She now spends most of her time managing an AI. This lad's sister's boyfriend just graduated with a degree in computer science, and he is struggling to find a job, partially because of AI, indirectly from AI through the fact that the Microsofts of the world have laid off many tens of thousands of programmers. So there's a dislocation right there today, and I don't have a solution. And it depends how things develop. The talk I alluded to a while back at the university last year focused a lot on the ethics of using AI. But do you know who are the biggest winners with AI today? Unethical people, spammers, scammers, are able to do their job, reach naive people and get their bank account data way more efficiently using AI. And I don't know how we stop that either.
Yeah, well, that's been true of a lot of new technologies. They can be used for good and they can be used for evil, and this is no different. But this is probably a bigger change.
It is.
I mean, we both lived through a bunch of inflection points. You know, the computer, the microcomputer, the internet, the mobile, you know, the smartphone, and on and on.
Yeah.
But this is a really big one.
So this phone, I worked on the Apollo guidance computer when I was at MIT in 64 and 65. We got to the moon with a computer that had 18,000 transistors in it. I and you and every other American have enough transistors in this phone to build 10 million of the computers that got us to the moon. 10 million. When I was in school, a decent transistor cost $1. There's close to 1 trillion transistors in this box.
Yeah.
And you know, the personal computer that you and I have our headsets, our screens attached to, only made something like 180 million last year. That number is declining because many people are satisfied with this, and we made 1.8 billion of those last year. So 100 times as many portable computers as desktop.
And there's a lot of speculation that the kind of phone that you're holding up that has a screen on it, a touch screen on it, it may not be long for this world. That there'll be different ways that we interface with the IT that we carry around on our bodies.
I and people working for me in this building invented the first chip that watches your finger move around on the phone. In fact, it's the same chip that is in this D10A. Mike, I sold over 1 billion of those over 8 years. I sold 85 million in 1 year to Samsung.
These are touch screen controllers?
Yes. Mm-hmm. We started out at $3 each and we were coining money. We ended up at 42 cents each because we were competing with a company called Happy Chip, and we gave up.
Sounds very Chinese.
Cannot compete with the Happy Chips of the world. The progress in technology is pretty astounding. I quoted Moore's Law the other day, earlier today, and it's screeching to a halt that we are now building transistors that are tens of atoms across. The chip in here and in here that we, again, invented in this building had a film thickness where 2 atoms mattered. 14 was too thin and the leakage current was too high. 16 was just right. 18, you couldn't program it, the flash memory. This was 25 years ago. 2 atoms mattered in the thickness of a film. Now we're getting to where atoms in the width of a transistor matter. And let me tell you, we will probably build very few transistors that are 2 atoms wide. So the density equation is most definitely coming to a halt. Clever things are being...
Are you saying that Moore's Law is coming to a halt, or that there's...
Oh, yes. Mm-hmm. Yes. The company I was CTO of, Cypress Semiconductor, we quit chasing Moore's Law probably 15 years ago when one camera that is used as a projector, really, to expose the wafers to generate chips. One camera cost us $57 million. You want a lens with that, the lens was another 20. And we could not afford to chase Moore's Law. Very few companies can today. In fact, there are 3 in the universe that can: TSMC in Taiwan, Samsung in Korea, Intel in the US. And a new factory to build state-of-the-art semiconductors is, I think last I read, somewhere between $30 and $60 billion. The $57 million camera that we gave up on 15 years ago is now a $300 million ASML, Dutch company, projection system to get down to a few nanometers. It's crazy. And, Cypress, my company, or the one I worked for, built its first fab for $10 million in 1980 small, and we had 2 of every machine because one will go down or need maintenance. And there are, 20, 25 machines. So we had 2 of everything for $10 million. Current setup is $300 million each for the most expensive machines. Very few companies can afford to play in that game, and today there are 3. And Moore's Law is coming to an end.
Yeah. So the opportunity for entrepreneurial startups in that particular part of the sandbox is pretty much over.
Yes and no. TSMC exists to build your chip. They would like you to build 10 million of them a year before they're really interested in talking to you. But when we gave up on Moore's Law, we moved some of our very high-end stuff to TSMC and others who were still chasing Moore's Law. So TSMC, unless they are bombed into smithereens by China when they take over Taiwan, is where you go if you're an entrepreneur with a great idea for a chip. It's frankly where NVIDIA goes for, I believe, most of their product.
I think so.
And state-of-the-art silicon can be had by you and I if we have enough money, but we don't need the $30 billion. We still need to buy thousands of wafers a year, $10,000, $15,000 a wafer, but you get a lot of chips on a wafer.
Yeah. The decimal point's in a different position.
Yes.
How long do you suppose it's going to take before the TSMC's fab in Arizona is producing meaningful quantities?
No idea.
Is that like a 10-year thing, or is
I'm not close enough to know. I know they are complaining about both the quality and quantity of fab workers. And there's a reason that I'm making this up, but I read somewhere 60% of all silicon by area comes out of China today because the quality, they've learned the quality matters, and they still have large numbers of workers that get paid less than the U.S. European workers.
Well, they just need to hire some more humanoid robots, I guess, right?
Oh, there are already zillions of robots. You're a human. What's the number? You give off several thousand particles per minute, mostly skin flakes. And any one of those particles is death to a chip on this wafer.
Oh, sure.
So you know what a clean room is? It's where we used to build semiconductors, still do, where intense filtration removes most of the crap from the air. But
and you have to wear a space suit to walk in.
Yeah, you wear a bunny suit and enclose your head. And today, the clean room is largely inside a machine. That the air that the people are necessarily breathing as they wander around these machines is way too dirty to use. But the machine itself has incredible filtration, and it produces either a vacuum where all the particles fall to the ground, or an air quality that is astoundingly good. But you still need some humans, but there are robots that carry a boat of wafers from one machine to the next. The machine itself is robotic. And so I'm a little confused because I've been out of it for almost 10 years, where all the people Okay, I'll give you, I got way too many stories that I've accumulated in 80 years, but there's a part called a 74-245 that's a 20-pin, 8-bit bus driver that we used in our very early products. Several companies make it, but Texas Instruments was the big one, and they lost the recipe. They went 6 months building very close to zero of these things, and the other vendors couldn't keep up. And this 80-cent part, I paid $20 for some to get enough to build my machines. The solution was found after 6 months. One worker in a TI fab had changed her perfume, and that volatile chemical in the air had polluted some machine's operation. Years ago, I was chief technical officer of this semiconductor company, and I dabbled in many different parts of it. I asked our fab manager, okay, how many knobs are there in a fab that you have to get just right before the wafer that comes out yields? 400. And can you imagine driving a machine with 400 controls, and if any one of them is wrong, that machine isn't going to produce? So it's a complex problem. Robots and automation are the answer just because humans give off all these particles. But this is a huge, long-winded answer. It's the only kind I have for the question, when's TSMC going to have the Arizona fab up and running and producing? They'll get there. Remember, it is nowhere near a state-of-the-art fab.
The one in Arizona? Really? Wow.
Yeah, they didn't bring the crown jewels. They may have prepared to someday. I'm not privy to what they did, but you and I as taxpayers gave them many billions of dollars to build this factory, and it can do many interesting chips today. Probably not the $30,000 NVIDIA AI chips that they now build in Taiwan. Samsung has got their state-of-the-art factories in Korea. Intel's are mostly in the US, although, frankly, Intel used to own state-of-the-art, is now a distant third out of those three.
Yeah.
So the world is pretty vulnerable if...
What happens if something happens to the photolithography company in Denmark, wherever it is that everybody
ASML?
depends on? Yeah.
Well, yeah, they are the only one making state-of-the-art lithography equipment. And they're obviously coining money because they now get $300 million for one camera. It's a pretty complicated camera. Are we going to do the next step? Sure, that's what humans do. But the returns are diminishing and the cost is going through the roof. Cypress, $10 million, bought two of everything in 1980. Cameras were $70 million in 2010. Today, they're $300 million. The next generation will probably be 5 times as expensive as that, all to chase the last vestiges of Moore's Law.
And Mr. Physicist, there's no substrate other than silicon that can keep Moore's Law alive by making smaller transistors?
Atoms are an angstrom across. Right? A nanometer's 10 angstroms. When you get... They're building what they call 2 nanometer today. That's a marketing number. It is nowhere near 2 nanometers. When I was last designing stuff, it was 90 nanometers. And that 90 nanometers really measured the pitch of for example, metal wires on the circuit, or the pitch between transistors. Today, the 2 nanometers means nothing. Is probably more like a 20 nanometer process. So 20 nanometers is 200 atoms across. Sure, we'll get to 100 atoms and maybe 50. Will we get to 20? I don't know. Maybe. But we won't get to 2. I can guarantee that.
Can we go into a third dimension on these things?
We are. There's 2 or 3 reasons to go to the next generation of silicon. The number of transistors you get on the chip, and therefore the amount of memory or the complexity of the hardware goes up. The other is the way things scale, they go faster. When you cut the key dimension in half, you get 4 times as many transistors on the chip. You probably get maybe twice as fast. So as we want to go faster at some level, you need to go to smaller. But again, we are nearing the end. I'm probably a doomsayer, and humans are clever and we keep inventing tricks. But remember, the last trick cost us $300 million each.
Got it.
Yeah, we will get better, but not a lot. And yet, let me tell you, there are, let's see, I can buy a 16 gigabit RAM, so there's 16 billion transistors. Now, RAMs are scarce today and the prices have gone way up, but I could buy that for $2 a few years ago. 16 billion transistors for $2. You can do an awful lot with 16 billion transistors. Now, that was a memory chip with very regular arrays in 2 dimensions, but random logic is way less dense. But still, I think a modern microprocessor might have 30 billion transistors on it, mostly in memories. But you can do an awful lot with what we can do today. Just the factors of 2 that rolled off the line almost for free are largely over. There may be a couple more, but we've gotten to a point where we can build some pretty sophisticated stuff.
Absolutely. It's an amazing, amazing field. Let me pull us back up out of the silicon weeds here.
Yes, weeds.
Because we've been talking for an hour and 45 minutes, and there's a whole bunch of other stuff I want to talk to you about. I could do this forever. Before I go any further, is it anything you can tell us about what Dynon has in the pipeline? What we can expect to maybe see out of Dynon in the next few years?
Of course not.
Well, I figured you'd say that, but you couldn't hurt to ask.
I am a noted blabbermouth. We are obviously working on stuff new or we wouldn't survive, but I can't really tell the competition what we're working on. More importantly, I can't tell you and your listeners, because if I tell them too much, they won't buy today's product. They'll wait until they get old and feeble and buy the new one. Many years ago, I had a fellow graduate student in physics. I doubt if you remember, but the Hewlett-Packard 35 calculator looked something like this. It was a $300 calculator back in the early 70s. And they kept coming out with a newer, better model every couple of years. And one of my friends, a physicist, said, gee, I really want one of these, but if I wait a year, it'll be more better. And I said, yes, Jim, but if you use that attitude, you will never buy one. There will always be a more better one in 2 years. You need to stop waiting when the product suits your requirements. Back then in 1970, today's HP 35 calculator is pretty damn clever. You can put programs in it. You can do very complex calculations that a physicist might do. This was before there was a PC he could use. He'd have to go punch cards and run on the big computer if he wanted that level of power. Same is true for my product and, frankly, my competition's also. What I do for you today is almost everything you need done in a cockpit. I can do all the flight data, the attitude, the airspeed, the altitude, the heading. I can do everything about navigation, where the airports are, where the rocks are. I can take your flight plan. I can run the autopilot and get you there. What I do from now on will be less dramatic than what I've done before, because today I do most of what you need. And maybe that's a negative sell on my product, but it's a positive sell on the product I have today rather than waiting for the product I'll have tomorrow. Let's go forward 5 years. 5 years, I'll have something really shinier, so will the competition. It probably won't get cheaper because my cost is not the chips and hardware and aluminum to make this. My cost is the literal many man years of software that go into the product today. It's also why I am not worried about more competition. I have one, and God knows he's big enough and good enough that he's a pain in my neck. But if you wanted to compete with me today, or you wanted to hire me to set up a new company to do it, I'd need $25 to $50 million just to feed the programmers for the years it's going to take to get all of the bits and pieces lined up. So, does Dynon have new things in the works?
That's exactly the answer I expected you to give me, but I had to ask.
Yeah, you had to ask. I've got 20 people doing software maintenance and improvement on the old products and working on new. Yeah. I can, even though I should not, talk a bit about Vashon.
Well, I was going to get there, but give me just a second.
You get there. I'll wait.
Okay. I just before we bring up Vashon, I just wanted to mention that from my standpoint, there's only one thing that your competitor does that you're not doing.
And that is?
That is telemetering data to the cloud that I have been trying to get you to do for the last 5 years.
Yes. And I understand and want the benefits that you bring to an engine health program, and that making the data transfer easier would be good. Let me back up. 8 years ago, I was on a panel discussion at Oshkosh over what's going to be new in avionics. And the Garmin guy went last, and he surprised me by saying, the future is all data links. And you may know that most airliners today can talk to ATC on a data link.
Mm-hmm. And their engines are telemetering stuff back to the engine manufacturers in real time.
Affirmative. Now, 20 years ago, I had a good friend who drove 47s for British Airways, and literally 2 minutes after takeoff, the engine department in Heathrow had the data from his takeoff from all 4 engines when he's in Kuala Lumpur or somewhere. So yes, the world has been doing telemetry from airplanes for a long time. I tell you, you undoubtedly know Tyson from
of course.
ForeFlight, and I sat with him at Oshkosh a bunch of years ago discussing how if our customers had ForeFlight, we could use his facility to get data to his cloud and then where it needed to go. You all know the history there. ForeFlight got acquired by Boeing. Neither we nor they have put in the calories to achieve that. You see that as important, particularly because it impacts your business. I agree it is important. Not everyone would, by the way. I've got several friends who think Big Brother is already enough in their shorts. And let me tell you, okay, I was chairman of the planning commission of my small town for 15 years. There is it's actually a pair of large roundabouts that get you over the freeway to our town. The only road into our town has to get across the freeway and get you on and off the freeway locally. And I tell you, when you use that roundabout, the Washington State Department of Transportation intercepts your cell phone's pings to the mothership, and they go to the mothership and say, hey, John went around our roundabout at time X. Please tell me everywhere he went in the 15 minutes before that. It's for a fairly moral purpose. If we know what all the traffic patterns are, we can work to optimize our roads. But if he also stopped at a porn shop or wherever, we're going to learn that too. So let me tell you, there is no privacy anymore. Go live in the woods.
Wasn't it Larry Ellison or somebody famously said that years ago?
Yeah, there is no privacy. One of my engineers did an experiment. He and his wife were out in the woods without their cell phones, and they decided, okay, when we get back, let's just talk about mattresses. Within hours, they were getting ads for mattresses. So everything you and I are saying is being captured by somebody on this gadget right now and deciding whether there's anything they can sell you. Now, that's not new. You remember the old pick up the phone on your desk 50 years ago, 70 years ago. The CIA could listen in on that phone anywhere in America anytime they wanted to. They had to get a court order if they followed the rules, but they didn't always follow the rules. So your telephone for the last 75 years at least has been a microphone picking up what you say when you're in range of it, and the authorities have access to that. So no, there is no more privacy. ADSB became a big deal to the privacy crowd. They're going to know where I am. And indeed, now they're using it to send me a bill when I land at airport number 47. Big brotherness of society is going to get worse, not better. My wife and I have endowed a chair at the University of Washington. It supports young faculty members in their first few years. One of the men who had it learned how to store data in DNA molecules. Astounding density. The amino acid on a DNA link is dozens of atoms. Maybe he could put 2 bits there. He then moved on to a computer that uses DNA. He's got a jar full of of DNA molecules that are doing computing. And the only practical application of that is he could simultaneously scan all 300 million security cameras that exist in the world, looking for that charlatan Mike Bush if he should ever walk by one of them. Literally, he had that much computer power. He had 10 to the 24 computers in this jar. So there is no privacy, and getting my engine data on the cloud to me has more benefit than cost, so I'm all for it. Yes, maybe you and I should figure out how to get that done today.
Let's do that.
Yeah.
By the way, do you know a company called Twist, TWST, I guess is the ticker symbol?
Probably not. I don't pay attention.
It is a company that is in business to manufacture custom DNA. You send it a bunch of base pairs, it cranks out DNA with those base pairs, and it's got some magic silicon thing that does that.
Yeah, a modern fab.
Yeah, it's just amazing. So, with all that said, what on earth possessed you to start an airplane company?
Idiocy is the obvious.
Somehow, given your background, Dynon seemed sort of obvious, like an obvious place to go if you wanted to turn your avocation into a vocation. But Vashon did not seem so obvious.
Okay, the joke is, of course, that Dynon is a hobby gone horribly, horribly wrong. 150 people now depend on it for a living, and is frankly more responsibility.
And 25,000 airplanes depend on it for a living.
Yeah, there are
too.
25,000 airplanes out there that use our devices to enhance safety, I like to think. But I'm an immigrant to this country. I arrived when I was 5 years old, starting with a taxi in London to a train to a ship to Montreal to a train across Canada, and I arrived in Seattle on a DC-3. The last
At what age?
At 5. I like to think, even though it is probably a conceit, that first airplane ride when I was 5 years old is planted in my head.
Imprinted.
Mike, if I hadn't worn these glasses, I would have joined the Air Force out of high school. I was so into at least thinking about airplanes. I already told you how I got a pilot's license the instant I could afford it. And I bought an airplane a year later with 2 of my oldest friends. We bought an old Luscombe, and my third share was $800. I bought an airplane for $800 in 1968. So while it was not my business for my first 60 years, it was always an interest. Dynon in
But flying airplanes and owning airplanes is pretty different from building airplanes.
Yeah, not really. It's just more of the same. It's a more serious case of the same disease.
Maybe so.
In 2012, Dynon was doing really well. Yes, we were only selling to the experimental market, but there were 1,000 experimental airplanes certified every year.
Yeah, it's the
And there were
fastest growing part of GA.
Yeah, there were about that many certified airplanes, so our potential market was still half the new airplanes. But there are three costs in building an airplane. There's the airframe, there's the avionics, and there's the engine. And 20 years ago, they were all roughly equal for a modern, ticked out airplane. We built the avionics. There's a third of it already, and I can probably get it wholesale. So that leaves me the airframe and the engine. Why not? So we started Vashon Aircraft when the light sport rules became available. And here was an airplane we could do for not the $25 million it might cost to do a Part 23 airplane. It did end up costing us $8 million, but we made a machine that meets all of the light sport regulations and started selling it. You may remember I sold the first dozen or so at under $100,000 each. Since then, my costs have more than doubled. My engine cost has more than doubled. So early on, I started an engine company, Double Crazy. And I've talked to you about it in the past.
Yes.
Airplane, the fleet is now, 150 airplanes. I had hoped to sell that in the first year, but I'm now building airplanes as fast as Continental can build engines. They are my limit. Therefore, I've got to get my own engine into production. But let me tell you, the steel foundries making crankshafts, the aluminum casters making cylinder heads, the aluminum casters using a different alloy making engine cases, and the myriad parts that go inside that case, my volume is not enough to interest anyone. So we're struggling finding vendors for those things. It turns out I now use the same cylinder head caster as maybe some of the big boys use, and maybe he has enough capacity he can give me some now. But we are still struggling with supply chain. So your question was, why did I get into this? Well, why not? I want to build airplanes. I'm already building 1/3 of an airplane in the instrumentation, and Light Sport let me build the other 1/3, the airframe, reasonably affordably. I now am stuck buying engines and they can't build them fast enough. And the biggest mistake I made was not putting a Rotax in that airplane. Because let me tell you, Rotax is a manufacturing powerhouse and they could build as many as I need.
Was there any chance of coming out with a Rotax powered version?
Of course, only a matter of time and money.
Is this a big change, really big change?
My most scarce resource, instead beyond engines, is engineering talent. First, I'm in a difficult location to hire it because I have Boeing and Microsoft and Amazon and Google and Facebook all here in town. And aviation doesn't let me afford to pay the same as Amazon can. And I include Blue Origin in there. I have lost 7 good engineers over the years to Amazon only. So I'm engineering limited, and I could put 3 guys for 6 months and we'd have a Rotax in the airplane. There are other things I'd rather do. If I told you we were working on other airplanes, they would have to shoot me. But on the other hand, I'd be an idiot if we were going to become a one-trick pony and have a 2-seat light sport airplane forever. We will most assuredly have a Mosaic airplane at Oshkosh. Now they're going to have to shoot me. Do I have other projects going in the airplane space? I most assuredly do. And do I have engines in development? Yes, I do. And I tell you frankly, because you're paying the bill for this video, I believe the services your company provides are something I'm going to insist on having in order to cover some of the liability for building and selling an engine to the world. We are going to have to do oil analysis every month. We're going to have to do vibration analysis if we can. And we're going to have to use any of the techniques you've developed to catch problems early.
Yeah, it's always struck me remarkable that companies like Continental, Lycoming, and Rotex don't provide a sensor package as part of the engine and make a requirement that the sensor data be made available to them as a condition of warranty. It just seems like such an obvious thing to do.
It's certainly obvious to me, and obviously it's obvious to you. Look, Continental is owned by AVIC, the largest aviation outfit in China. They have 500,000 employees. Lycoming is owned by Textron, and they're a big conglomerate, and Cessna makes all of his money in the business jets. It may be obvious to them, but it's down in the noise.
The
it's
engine
obvious
that's
to me because lawyers are the biggest enemy, I think, of small aviation vendors today. And we want to do everything we can to enhance safety. And engines quit. It turns out engines quitting isn't what kills pilots. It's in the statistics, but it's down around 8%.
Mm-hmm.
And we are supposed by rule to be able to get on the ground safely even after the engine quits. So this problem is multitasking. The engine quit, and all I'm focusing on is that, not where's the best place to put this thing right now. But it still is an obvious target for the lawyers when someone dies. Collection of data is a useful thing, and I'm going to highly support it. And you've woken me back up to, 8 years ago, I looked at getting our customers' data to the cloud, not with your use of it in mind per se, but others. And maybe we'll look again. The problem is we need someone who's got the radio that goes to the cloud. Garmin has theirs. ForeFlight is the other big player. And they are now, Boeing sold them off with JEP. So
might be able to do business with it without dealing with the Boeing, the Boeing contracting people who are just impossible.
I will second that, but I would hate to go on record of saying anything untoward about Boeing. Okay, I'm in China many years ago talking to a young lady who had personally bought 60 airliners and arranged the financing and the leasing of them. So I asked her, okay, what does a new airplane cost? And this was years ago, but she said, well, 737 is $80 million list price, but you can negotiate down into low 40s. Interesting. And then I assume Airbus is the same. No. Boeing gets a $1 million premium because they're Boeing. I'm willing to bet they don't anymore. Yeah.
Interesting. So the engine that's in the Ranger is an 0200?
Affirmative.
And the engine that you're building is a relative of an 0200?
Yeah, again, they're going to shoot me for talking about it, but it's been running for a long time and would be in airplanes if the supply chain existed, but it would, of course, be way more modern and be an IO 200.
Mm-hmm. Very good. Well, if it makes you feel any better, John, the chances are that this episode is probably not going to drop until very close to Oshkosh.
Okay.
So
by then my secrets may be out.
Yeah. So don't worry too much about that.
Okay. But yes, we have additional airplane engine and avionics stuff in the works, but you won't see a lot of it at Oshkosh.
Now, this engine, this is not going to be certified under Part 33, right? It's going to be certified like a LSA?
Never say never.
No, I didn't say never, but I mean initially. Yeah. That's the way you're...
Never use absolutes is something I live with.
Right.
Initially, the IO 200 will be certified under ASTM rule, which
and what is
largely certification rules.
And how would you compare the process of getting something certified under ASTM versus having it certified under Part 33. Is it a lot easier?
I have never certified anything under Part 33, so I don't know. I am working under Part 23, I'm working under Mosaic, and I'm working under ASTM. Overwhelming benefit of ASTM is you have to meet basically the same or more stringent requirements. ASTM makes it a 4G airplane, whereas Part 23 makes it a 3.8G airplane. That's a small difference, but the technical specs are almost as hard.
But you're dealing with a different set of people, right?
The gigantic win is you don't have to do it the FAA way, and you don't have to get them to agree on how you're doing it. At the end of the process, you have to raise your right hand and swear that we meet the requirements and have data and testing that shows we do. That is order of magnitude reduction in the bureaucratic part of getting certified. The FAA, as well they should, has the right to come in and audit you, and they have, and show us where you tested the wing to G's. And we can. We have videos, and we have all the data taken during that test, and we have the calibration on the load sensors. So yes, we did what the requirements say we had to do, but we were selling product by the time the FAA said, prove it.
Right. So that's a huge difference. So they're not involved. They're not involved in the process. They're involved after the fact as an auditor, maybe.
Right. They were also involved in writing the rules. And
the ASTM. Yeah, they're on the committees, right?
They approved the rules. And the rules were very largely a cut and paste of Part 23 rules. Mosaic, same deal. Mosaic is largely, not completely, because allowances had to be made for some of the airplanes out there that made sense to become Mosaic but didn't meet stall speeds, for example. But the rules are largely cut and paste from the FAA's existing rules. The bureaucratic load is what is reduced. And you know what a DER is. It's someone who does the FAA's work because we are far too busy to do our own work. I said I was going to say only nice things about the FAA.
No, I had a long podcast about DERs with Jimmy Tubbs, so yeah, very familiar with all of that stuff.
The FAA tried to make him one way back when, but DERs are very expensive. They're kind of like lawyers, and you have to hire them because the FAA...
That sounds like a quote for a clip from this podcast. I love it.
Way too busy to come and monitor your test. I will give you another anecdote that is itself funny. I may be working on an airplane that at one point we considered certifying jointly in the US and China. Obviously, there was some money from China involved. I met with the head of aircraft certification in Beijing, along with the investor and some very senior Chinese airplane developers. The question to the regulator was, should we do a joint development, US and China? Oh no, he panicked. Cirrus is owned by Avic now. They're a Chinese-owned company. They built a 3-seat trainer a few years ago. I don't believe they currently market it. We were looked at as the Avionics in it, so I knew a bit about it. Do you know how many CAAC employees they wanted to send to Duluth, Minnesota to observe the structural testing of this new airplane? I tell you, the FAA would probably send 2. The answer is 400.
Oh my God.
400.
There aren't 400 available hotel rooms in Duluth.
That was exactly my reaction. There aren't 400 first-class hotel rooms in Duluth, Minnesota. They ended up...
Don't get me wrong. Duluth is a very nice town. But
yes, and Cirrus, I think, is a quality company. They ended up, and again, this is literally quoting the head of aircraft certification of the CAAC. They ended up compromising on 40. The FAA would probably send 2 or maybe 1. So this was a boondoggle and a terribly expensive boondoggle. I told you I am now working with a company we own in Europe that does all of its cert with EASA.
Mm-hmm. Mm-hmm.
EASA is a business. They don't look at your paper until you've sent the check. There are advantages to having the FAA and making many of the functions of the FAA a community-funded function. For example, air traffic control. If you're flying from Seattle to Boston and you cut the corner after Chicago to go up through Canadian airspace, you will get a bill.
Mm-hmm.
It'll save you a little bit and they'll take their share. But many of the world's aviation authorities have, because all governments are always looking for more money, have monetized their function.
Absolutely.
Enough said.
I remember years ago, I flew down the Caymans quite a bit.
Yeah.
And I'd get bills from Jamaica Center.
Mm-hmm.
And I never talked to Jamaica Center. I was talking to the Cuban guys, but yeah, they always want to send you a bill. I didn't pay the bill, by the way.
Good for you. I knew you were a rebel at heart.
At any rate, this is I'm really looking forward to seeing this engine. So it's going to be interesting.
Yeah, the most interesting
probably be something at
it,
AirVenture about that.
Probably not. The two interesting, we were considering having an engine there on a stand to show that it's real. We probably won't. The interesting thing about the engine is I will be able to build it for about half the cost of buying one from Continental.
That
and
much?
2, I'll be able to get 25% more horsepower out of it than they do.
Mm-hmm, for sure.
Remember, you and I were either not yet born or toddlers when the O200 or its predecessors were first certified.
Yes.
We've learned a lot about how engines breathe and what timing and fuel injection can do. So our new engine is quite a bit more better. We probably won't be able to give the customer the whole 125 horsepower because that would involve totally repeating a lot of flight tests. But what we will be able to do is give him maybe 10% more and to maintain that to a significant
all the way up
altitude.
to altitude. Yes.
Yep.
Yeah. Just derating it. Yeah. That makes perfect sense.
Yep. So it will be a way better engine in many respects. It won't have 75 years of experience and history. And
let me ask you a question about the Ranger, because one of the things, I've been involved a lot in the maintenance of aircraft, and we always joke about the fact that the people who design these things are never the same people who have to work on them, and they're designed to make mechanics' life difficult. What was your approach in terms of maintainability when you were designing the Ranger?
Gosh, I'm not sure we had one other than everybody involved owned and flew airplanes. Okay, I got a boat. It's a nice boat. It has an engine compartment with a deck that lifts up. The batteries are down in there. And if your visitor leaves the key on and the batteries go dead, they are down in a compartment that needs the batteries to raise the lid to get at the batteries.
What's wrong with this picture?
Yeah, okay. I drive my wife's hand-me-down Lexuses, and the engineers at Toyota, when they designed my Lexus, if the back door doesn't shut completely and stays open a crack, the dome light stays on. If the dome light is on, I better keep the headlights on also. Guess what? The programmer of this system, decided he would rather 10 hours later I run his battery down to 0 volts than decide maybe I should save enough to start the engine and shut the lights off anyway. You have a computer history. Would you ever be that dumb with a computer system? The customer wants me to kill his battery over 10 hours so I can keep a dome light on. So you're right.
Well, the good news is the next car you buy, all of the software will have over-the-air updates so that when something like that happens, they can fix it and
For
send
a
it out to all the
fee, yeah.
vehicles.
So what did we do? The basics of the Ranger that improve maintainability is that it is big. One of the things that the light sport rules gave us was a speed limit, 120 knots. Can't go faster than that. Therefore, the cost to make the cabin 4 inches wider than my Cessna 180 was very little in terms of speed. That made the cowling wider, so the engine is not quite as tightly cowled as many are. That gives the mechanic more room to get in there. We did look at what things are going to break and how do you get at them.
That's the important thing. Yeah, maintenance access. That's really the big thing.
So we thought about it. Did we do a better job than others? Well, yes. It's not nice to speak ill of the dead, so let's do it. The Cessna Skycatcher was a decent airplane. I believe that Cessna tested all of the structural requirements, as did we. I believe most of the other 128 certified light sports did not. The rules didn't require you to do the test. They required you to have engineering data that showed you would pass the test. We had all that, and we failed maybe 1/4 of the structural tests we ran, and had to put more metal in. But the Skycatcher had a kind of unique clamshell door. I have a float plane. I've probably taken off 5 times in the 42 years I've owned it, with the door unlatched, and the door pops open. And the key when that happens is to realize, do not focus on the door. You'll die if you do that. Focus on landing the airplane, because you can't, the suction on the door is
But yeah, there's no way to close it.
You can't move it. Just get it back on the runway at 0 miles an hour and shut the door. On the Skycatcher, if you didn't latch the door, it flew up and beat itself to death on the bottom of the wing and was a $10,000 bill. They added additional latches and protections, but that was one they didn't catch until customers had the airplane and did it. The other key is making repairs affordable. Where is it? I won't bore you, but there's a little piece of metal that holds the door. You know, when you open the door on a car or an airplane, it goes to a detent, and it'll stay there. And then you have to pull it past the detent to close it. That is a little piece of stainless steel on my airplane. I could build 100 of them at $2 each, and they are now $950 each from Cessna to repair a thing that wears out, because it's made out of soft metal and it goes over the bump. I've come that close to building 200 and giving them away, but the people I give them to would then have to either jump through hoops or break the rules to put it in their airplane, so I haven't. But $950 for something that can be made for $2 is a real ripoff. But the certification rules give me the right to do that. You can't make Well, there are such things as owner-supplied parts, and I have done that on my airplanes, and it's a good rule. But the fact that I must buy the replacement part from a guy who owns the TC or STC makes those parts horribly expensive. We have not done that yet to our customers. And we've had customers break things. We had a student in Hawaii who stalled the airplane 23 feet above the runway. That's bad. Came down awful hard and, in fact, broke a landing gear off. He knew he was in trouble. He had already goosed the engine, and he managed to go around with this landing gear hanging from the hydraulic line, bouncing against things. The student pilot, after totally screwing up a landing and breaking the airplane, flies around and does a perfect greaser landing, kept the airplane on 2 wheels until he got the motor stopped, never had a prop strike, recovered astoundingly well. But don't stall the airplane 23 feet above the runway if you want the landing gear to survive. The requirements and the actuality don't cover that event. But let's make sure you can get the old broken landing gear out and a new one put in without having to take the airplane all apart. So yes, airplanes, like any modern complex gadget, need thought put into maintainability. Cars do not do a terribly good job of that. My next-door neighbor needed a new clock for his BMW, something they probably built for $6, and it was $1,500. So in many products today, the ongoing maintenance is a revenue source for the vendor.
And I don't mind it being a revenue source for the vendor as long as
if it's reasonable.
It's not ridiculous, yeah.
Yep, and of course.
For parts that have to be replaced regularly because they wear out, like the door detent that you're talking about. If things get ridiculous enough, it motivates somebody to develop an STC.
Yes. And if the volume were high enough, I was mad enough, I would have done that.
Right. I did a study once, it was a few years ago, of Lycoming parts prices.
Yes.
And what I found was that Lycoming parts for which there was a PMA equivalent by Superior or somebody.
Competition's a wonderful thing.
Were half the cost of Lycoming parts where Lycoming was the sole source. And it was just an absolutely predictable pattern. It was just a 2-for-1 ratio.
Yeah.
So that's why I kind of hated for example, to see ECI go away, because we need guys like that to keep parts prices reasonable and to
by the way, I didn't start an engine project in a vacuum. ECI was a 50% partner at the beginning of the project.
So you were working with Jimmy?
I was.
Great guy, wonderful guy.
Real gentleman, great guy.
Yeah, one of my favorite people.
Yep.
Right along with you, John.
Ha! Well,
really good people. You meet some awfully nice people in this business.
I got to tell you my Jimmy story. When I first met him.
You only have one?
No, I got one that worked. When I go to Florida, Sun and Fun, as an icebreaker with potential customers, well, where are you from? And if it's from Florida, I always ask, well, when did you last see an alligator? And the answer was, oh, last Thursday or on the way here. And I'm thinking, you live here on purpose. So with Jimmy, when I first met him, I said, well, when did you last see a scorpion? Because 3 times as many Americans are killed by scorpions as snakes. And he said, oh, 2 weeks ago, a bastard got me right here. And not only did he see one, it attacked him. And again, people live in Texas on purpose. It's crazy.
Yeah. Jimmy is at least our age, if not a little older, I think. And he's still riding his tractor, and he's indomitable. Wonderful guy.
Mm-hmm.
So anyway, you took some avionics and you built an airplane around it, and now by the way, how did knowing what the avionics suite was from the get-go affect the design of the airplane? It must be kind of interesting to do it that way.
Well, obviously, every airplane we build has a Skyview avionics system and an autopilot in it. And an autopilot is, in fact, a pretty useful safety device. For example, the biggest killer in light airplanes today is loss of control, and the airplane breaks up at altitude. Part of our system is a blue button right there called level. You push that when you're in a panic, and the airplane will straighten itself out and fly straight and level on the current heading and give you an option to do a 180 with the autopilot to get out of the cloud you just flew in. The fact that that's an expensive extra on most airplanes gives us a benefit, and we don't build an airplane without it. From your bailiwick, we don't build an airplane with a rather complete engine monitor and data logging capability. Safety features inherent in the full avionics suite I believe mitigate some of our legal risk. Few of our customers will die than the customers who buy a 40-year-old 172, although that's been a very, very safe airplane during its existence. The other thing we did for safety is one of my aeronautical engineers said, one reason the 172 is so safe is it's got a big tail and a big rudder. And so I said, okay, then we're going to have a big tail and a big rudder, and we do.
Mm-hmm.
So,
by the way, you mentioned that you had a deal with the 120 knot speed limit for
we did.
LSA. Does Mosaic lift that speed limit or raise it a little bit, or is it?
Undoubtedly, yes. I can't quote the rule today, but
so
yes.
Does it automatically raise the speed limit, or is there something you have to do to recertify it under Mosaic or something?
No, you have to certify under Mosaic. It doesn't automatically change light sport rules. But there will be a fair number of very sexy glass European airplanes at Oshkosh that will be, quote, Mosaic ready, because Mosaic won't exist as a legal thing you can build an airplane to on the date of Oshkosh. Perhaps a few days later, depending on the FAA and the committee. But by rule, yes, you will have to if you want to be a Mosaic airplane, you'll have to meet all the Mosaic rules. Now, the good news is if you already meet ASTM's light sport rules, you largely meet it. Mm-hmm. But if you want more gross weight, in our case we do, if you want more speed, the testing will have to show that those things are safe. And the requirements for more speed will be obviously steeper than the requirements for ASTM. In our case, the requirements for more gross weight means we have to go to look at every one of our tests, which we did for a higher gross weight because you may remember the float plane ASTM rules allowed another 110 pounds.
Right. Uh-huh.
But we are going to have to do things to our landing gear because they met the land plane ASTM rules for the 1320-pound gross weight. If we want more gross weight, we will have to, and obviously are, beefing up the landing gear. So different rules.
But bringing it into the envelope of Mosaic is a lot less than starting over again. You're mostly there as an LSA.
Because both ASTM and Mosaic are largely copy-paste of Part 23 rules,
mm-hmm.
The rules are the same. But because Mosaic allows more seats, more gross weight, and more speed, there are many rules that will require testing to those higher constraints. One of the reasons we probably won't take our 125 horsepower engine and put it in a Ranger at that horsepower is you would be able to go a lot faster, and that would require a lot more flight testing to make sure you didn't exceed the structural safety margin that we have already tested for.
Mm-hmm.
Make sense?
Yeah, sure.
And many of the safety structural requirements are based on what's called the dive speed. How fast can you go when you stick the nose down? And drives, for example, I believe that drives the most stringent requirement for wing load capacity. So if you allow the airplane to go a lot faster, the dive speed will be a lot higher, and the G loading you have to test for will be a lot more pounds. So in order to save many $100,000 worth of flight test, when we do a Mosaic, we will increase gross weight, not airspeed and not engine horsepower. If you want the 150 sexy European airplanes, they have tested to that.
Okay, so you kind of seem to indicate that the Ranger, you sort of think of it as kind of in the same general class as a Cessna 172. What's the price differential?
That's not fair. It's very similar to a Cessna 150. Same engine, same number of seats,
right.
Very similar useful load.
Okay.
Maybe our next airplane will be more like a 172 or maybe a 182.
Right. what I was trying to get to, and maybe I'm not going to be able to get there, is to get some sense of the cost differential between between the Vashon airplane and a similar one from a company like Textron or something. And maybe there's not a good one-to-one comparison.
So last time I asked at Sun and Fun, new 172 is $640,000. And I can get you one near the end of 2028. And you won an autopilot with that. That was another $40,000. Because they can. They do 100 and what? They did 180 something like last year. That's about the market, and only a flight school can afford that now, although I don't know how a flight school affords it. If and when we have a 4-seat airplane, it will obviously cost a lot more than a Ranger because a certified engine for that airplane will cost a lot more. But it won't be anywhere near what a 172 now costs.
Mm-hmm.
On the other hand, the 172 has a reputation and a sizable fleet that give it a huge advantage.
Yeah, I bought my first airplane. I was 25 years old, and that's back before I decided I wanted to be an entrepreneur. I was working for Computer Sciences Corporation. They were paying me what seemed like a lot of money at the time. And I bought a brand new Cessna 182 in 1968, my first airplane. And I picked it up at the Cessna Delivery Center in Wichita, and then I flew it back home to California. A pretty big deal for a 25-year-old kid.
Yep.
So it was a $25,000 brand new Cessna 182. $25,000. It's now,
so now it's a factor
900,000
30 more.
It's just amazing.
So there was a panel discussion at Oshkosh many years ago that included the Clapmeyer brothers, the Cirrus founders, and Burt Rutan. And they tried arguing that airplanes would cost the same in constant dollars.
They don't.
And they don't. Rutan called bullshit on that. He bought his first airplane in 1964, shortly after he graduated. And I remember the story. I believe I'm quoting him accurately. He had to borrow the money to buy it, but the price was literally his salary. So an annual salary bought a new airplane. He asked, what does your airplane cost today? And today that's what? North of $700K. That is
Cirrus?
not
That's north
that
of
is
$1 million.
not the SR20. I think is 700.
SR20. Okay.
700K is not the starting salary of any engineer I've ever met. So you're right.
Well, I had another way of calibrating this.
Yeah.
Which I called the Cadillac index, although that's probably an outmoded term. But the notion was, how many top of the line luxury cars would it take to buy a new airplane? And at the time I bought my brand new Cessna 182 in 1968, you could buy 4 Cadillac Eldorados for the price of that Cessna 182. Today it's about 12.
Yeah. Yeah. So that reminds me, you'll appreciate this. There was a magazine article in my youth that wanted to figure out how to quantify the maintenance a given airframe required. And they decided the unit of maintenance was a British sports car. So a BSC was
That's a very high unit of maintenance.
Very high end of the maintenance spectrum. So, you buy a Piper Warrior, maybe it's 3.5 BSCs. But you buy some other kind of trickier, fancier airplane, it might be 6 or 7 BSCs. And they started qualifying these numbers for different airframes.
Well, that's great. I love that. I owned when I was at Dartmouth, I owned a Rover 3-liter saloon. And I had a friend when I was at CSC who bought a Jaguar XKE, which was just like the most beautiful car that was ever built. And within about 2 years, he was ready to push it off the end of the Santa Monica Pier because it was always down.
So the only serious psychological damage I suffered as a youth because my parents were poor was not having an MG when I turned 16. Now have one, and let's say the wheels have only fallen off the car while I was driving once. Yeah.
Okay, so John, we're probably going to have to wrap things up because I think the engineers are going to throw us off pretty soon.
Yep.
What is your prognosis for the future of piston general aviation? Is it going to survive?
Good. Not good. I can still remember in the third grade, instead of doing what I was supposed to be doing, I was drawing pictures of airplanes. There was a youthful passion for flying. It was so cool. I think today, this machine and the stuff on it is a more serious drug for today's youth. Believe that anything I might have had in the development of this was not doing humanity a favor. The average teenager in America spends 4 hours a day on that machine, and that is going to cause a serious mental deterioration in the quality of young people being people. They need to do more things, and they need to meet more people and interact more with people.
I think it's a combination of the screen and social media. I think it's just
exactly
a catastrophe.
The net result is flying is no longer the coolest thing a youngster can do. Couple that with its 7 Cadillac Eldorados if you want to buy an airplane. The fact that the cost of everything in aviation has gone up way faster than inflation, meaning it costs way more hours of work to get a unit of fly, makes that harder. The good news is that as a society, we're becoming richer, but that rate has slowed down a bit too. AI may help that or hurt it to Joe average. We'll have to wait and see.
I think the Ranger brings the Cadillac index down to back around 4, doesn't it?
Oh, yeah.
4 or 5.
Well, we started out at 99K. Everything has doubled. We're now up at 170. So even the Ranger is not as cheap as I wanted it to be. I tell you, Mike, I might have made a mistake in how important price was. Maybe not. Had I done the Rotax engine, again, I've told you is my biggest mistake, even though I wanted, quote, a real airplane engine, the cost of the Rotax would have been a lot lower than my current cost of an 0200. But yeah, we're going to, as an industry, have to work on costs. And unless we want things to die, how does a youngster today afford to get an airplane or an airplane license even? It's difficult. Now,
but
that's the bad news. Let me give you the good news. Flying is still the most fun thing you can do in the state of Washington that's still legal. It is a really cool experience. And when people get a taste of it, they tend to like it. So getting more youngsters into airplanes, the EAA Young Eagles program, I think, is a very good one. But getting more kids into aviation is important, but making it affordable for them to stay is also important.
Yes.
So I believe there will always be general aviation. A Cirrus SR is now north of $1 million for a fixed gear airplane. There are a lot of people
very nice one.
For a nice one. Don't get me wrong. It's a very well turned out, well done machine.
But still, who can afford it? Nobody in their 20s, probably.
People for whom 1 million is a small fraction of what they got. And it turns out there are a lot of those. Now, when I was a kid, the state that had the highest per capita millionaires was Idaho. Because if you owned a ranch in Idaho, you had to have so many acres to make it pay that was worth more than $1 million. Today, $1 million ain't what it used to be. So now to buy $1 million airplane probably means your net worth needs to be 10. And there are people who have that. There are the billionaires of the world that can afford anything they want, but they don't want to fly their own light airplane. So the cost side of the equation is getting out of hand.
Yeah, but we need to get people into it, when they're young, like you and I did. And I kind of like what AOPA is doing with its high school thing. I would love to
Yes,
see
I
that happen
agree
a
with
lot
that.
more.
I agree with that. So we need to keep working on costs. The good news is the cool factor when you get in an airplane and fly and look at the world is
That'll
still
never
a
go
cool
away.
factor, right?
Yes,
It's
that'll
still
never
why
go
I
away.
own little airplanes.
What do you think? What do you think about diesels? What do you think the future of diesels is for personal GA?
I think the cost is higher than the benefit.
Do you?
The weight is huge. You don't have to carry as much fuel, so that offsets that somewhat. But getting a diesel into an airplane is a complex thing. The guy who runs the Vashon operation for me did it in a prior life, and he swears never again. Pretty difficult.
Yeah, of course they're more fuel efficient, but what's more significant is they don't use a boutique fuel. They use fuel that's available.
Yes,
everywhere.
And that's a big issue, and I am skeptical that a lot of the attempts to get the lead out are going to bear fruit, that any engine we're working on a better run on auto gas.
Yeah, well, that would be very helpful. But you're not.
The world
You don't want to build a diesel.
The world wants diesels for those obvious reasons, but they are a heavier, more complex engine.
Yeah, I was disappointed that Cessna bailed out of their diesel programs, because you just need one person, one operation to get it to critical mass. I guess Diamond is the closest.
Yeah.
Right now.
Yeah, they are. I can't remember what the price premium to buy a diesel Diamond over a gasoline one, but I bet it's significant.
Well, John, this has been a delight. I would love to have you back for another episode, because I think we just got so much we could be talking about.
You and I could do this for hours.
But in the meantime, did you think it was going to be this much fun?
I didn't realize you and I were the same age. I've always thought of you as a youngster. No,
I just looked that way.
Yeah, okay. Well, that's worth it.
But at any rate, let's do it again. In the meantime, work on telemetry.
Okay.
And I can't wait until you can tell us about the next thing from Dynon and the next thing from Vashon, because I'm sure it's going to be really exciting.
We hope so. Thank you, Mike, for having me and keeping this thing rolling.
Yeah, so this was a delight. Let's plan on doing it again. In the meantime, everybody, thanks for tuning in. And I don't know how many of you made it all the way to the end, but we love doing these long form things. You never know where they're going to go, but it's always interesting. So please like, follow, subscribe, tell your aviation friends about the podcast, because we have very interesting conversations with the most amazing people. And thank you, John. We'll see you again on another episode of Aviation Masters. Bye, everybody.
Thank you, Mike. It was fun to be here.